In this video I will show the proper way to plan a mission for the Vertical Technologies DeltaQuad. When starting the ground control station, it will enter the fly screen. To plan missions, the vehicle does not need to be connected. We can enter the mission planning screen by clicking the Plan button located here. In this demo we will plan a survey mission to map the field shown here on the satellite image. When planning missions, we must always consider the wind direction. In this demo we will assume the wind is coming from the east. That means it's blowing from the right side towards the left. Start by placing the first waypoint, which will be our VTOL takeoff waypoint. To place a waypoint, we click on the plus symbol and then select the location on the map. In this case we will be placing it approximately here. When the first waypoint has been placed, the system will place the planned home position right next to it. We can drag the planned home position to the location we intend to take off from. The first waypoint will automatically be set as a VTOL takeoff waypoint. That means that the DeltaQuad will take off as quadcopter to the selected altitude, transition to fixed wing and fly towards the VTOL takeoff waypoint. The recommended altitude for a takeoff waypoint is 60 meters. The VTOL takeoff point should be placed at minimum 300 meters distance from the takeoff location and should be facing the wind. The distance between a waypoint and its previous waypoint is indicated in the top bar here. In this case it says 445 meters, which is more than the recommended 300 meters minimum distance. As most survey missions are flown higher than 60 meters, we will place a second waypoint for the vehicle to increase to the altitude we require. Next we're going to position our survey mission. We can do that by selecting the button Pattern and then Survey. We can adjust the survey mission by using the white dots surrounding it. So we can select the survey area we're trying to map. For mapping missions we always try to maintain a slightly overlap with the green area that indicates the area where pictures will be taken. So when we're going to map this field, we try to have at minimum that area covered by the green color. As indicated, the wind is blowing from the east. Currently the survey mission has been set to fly the lines from north to south and from south to north. That would put the vehicle in a crosswind position, and this is not recommended. We can change that orientation of the lines by changing the angle in the survey item. In this case we want to rotate the angle 90 degrees. To get the best performance we make sure that all the lines are full straight lines. You can modify that by slightly moving the corners in such fashion. It's also possible to make something other than a square. By clicking this item you introduce a new button to be able to create as complex a shape as you like. In this case we're going to leave it as a square. It is also recommended to have the entry point and the exit points on opposing sides, and to realize that we'll make sure that the vehicle flies one more line. And now we see that there is an entry point and an exit point on a different location. This will make it easier to plan our return mission. Next we're going to see what options were selected in the survey. In this case we are using the settings for a Sony a6000 camera with a 16mm lens. The overlap set is 70% front overlap and 70% side overlap. We selected a ground resolution of 2.5 centimeters, and the system then calculates that we will need to fly at approximately 100 meters altitude. The angle we discussed already, and the turnaround distance we set to at minimum 100 meters. Depending on wind conditions and altitude you might need a bit more. We can change it here to 120 meters all the way up to 200 meters if required. We can rotate the entry point of a survey mission. If the entry point is not convenient for us, you can choose any of the four corners by clicking the Rotate Entry Point button, and that will make the entry point rotate until you get to the point where you feel comfortable entering your survey mission. Last option that we always want to set is the fly alternating transects. When we do not set this option, the vehicle will fly in a zigzag pattern down. But that means that it has very little space between the two lines, and we can solve that by flying alternating transects. When we select that option, the vehicle will fly constantly skipping one line and eventually hitting the end, and near the end it will fly back up and follow the lines it had previously skipped. So now that we know the altitude that the survey mission is going to be flown at, given the 2.5 centimeters per pixel setting, which is approximately 100 meters altitude, we can head back to our number 3 waypoint, the waypoint we set to make a clean entrance into the survey. So first we want to make sure that the altitude for the entrance waypoint is set to the same altitude approximately as the survey mission, in our case about 100 meters. Then we also want to make sure that the waypoint makes for a clean entrance into the survey mission, so that when the vehicle starts its first line, it has a clean entrance on a straight line into the mission. Next we're going to plan our return path. To do the return, we want the vehicle to descend to an altitude of approximately 25 meters and come back to the, in this case, the same location where we took off from, making sure that the vehicle is facing the wind when performing the back transition to commence landing. To do this, we will place an additional waypoint approximately here. And here we can see that the altitude is still set to 100 meters. We want the vehicle to lower down to 25 meters altitude. Again, we check the gradient, in this case minus 9%, which is well within tolerance. The maximum descent percentage is minus 15. The final waypoint that we're going to set is the VTOL land waypoint. We want to get that close to our home, so we click it right next to it, and then we can drag it straight on top of our planned home position. To change a waypoint into a landing waypoint, we go to the waypoint category button where it says waypoint. We click that, choose category VTOL, and select the item VTOL transition and land. The VTOL land waypoint should be at minimum 200 meters away from the last waypoint. In this case we are 725 meters away from our last waypoint, so that is good. The altitude for the VTOL land waypoint can always be left at 0. Now that the mission is set, we can perform some checks. First thing we'll check is the total mission distance, which is indicated here. In this case 27 kilometers, which is well within the maximum of 80 kilometers what we can do for a mapping mission. The system will also indicate the maximum telemetry distance, in this case about 1400 meters, which is the maximum distance between our home location and the furthest point in our mission. It also indicates the estimated flight time, however the ground control station cannot predict this accurately and this can be ignored. The planning screen also gives us an elevation overview, which is located here. Here we can see our takeoff point, which is ground level, then our VTOL takeoff at about 60 meters altitude, next to 2 waypoints at approximately 100 meters altitude. Here we descend on waypoint number 130 to 25 meters altitude, and finally we touch down. The white bars underneath indicate an estimation of the ground elevation. This information is taken from online sources and is only an estimate. If it gets too close to ground level, it will be indicated here. Now we can proceed to upload the mission. To upload the mission, the vehicle obviously needs to be connected. When the vehicle is connected, the upload function will be enabled here. When we click upload, the mission will be sent to the vehicle to be able to be executed. After the mission has been successfully uploaded, it is recommended to download the mission and see if the mission is identical to the mission that was uploaded. This is a verification step to make sure the mission has entered the vehicle correctly. It is also recommended to test every mission in the simulator before executing it in real flight.